You are probably incredibly used to the way AI assistants operate at this point. I mean, you open an app, you type in a question, maybe something pretty complex like asking it to summarize a long article, and boom, you get an instant rapid-fire answer.
Right, yeah, instant gratification.
Exactly.
Yeah.
We have all been conditioned to expect that immediate gratification. Like, the ultimate metric of a good AI over the last few years has just been speed.
Oh, absolutely.
But I want you to imagine a completely different paradigm today. What happens when an AI is intentionally designed to do the exact opposite? Like, what happens when it's built to slow down, grab a virtual cup of coffee, and genuinely pause to think before it speaks?
I mean, it feels completely counterintuitive, right? Especially with everything we've been handed by tech companies lately.
Yeah, totally backward.
We've been living in this era where a chatbot taking, 5 seconds to answer is considered completely obsolete. But shifting that goalpost from speed to deliberate, really profound contemplation, that is what fundamentally altered the trajectory of artificial intelligence.
Which brings us to our focus for today's deep dive. We are looking back at a massive milestone from 2025, which is Google's Gemini 2.5 Pro, specifically a feature that was called Deep Think mode.
Right.
We're going to figure out how this thing actually dismantled the rapid-fire chatbot model by using something called parallel reasoning.
Yeah.
We'll get into the benchmarks, the limitations, and the ethical questions it brings up for you and for society as a whole.
And I think the crucial thing to understand right away is that deepthink was not just, a fresh coat of paint or a slightly better algorithm.
Right.
It was a complete structural overhaul of how, and honestly, more importantly, when computational power is actually spent.
Okay, let's unpack this.
Yeah.
Because the way a standard AI processes a prompt, it's actually quite linear, isn't it? Like, if I ask a standard chatbot to solve a riddle, what is it actually doing behind the scenes?
So it's using what we call a linear chain of thought. When you give a standard model a prompt, it generates the response sequentially. It's essentially looking at the words you typed and then predicting the next most mathematically likely word, and then the next and the next in this straight single-file line.
Just one word after another.
Exactly. I mean, it is highly sophisticated guessing, but it's still just walking down a single path. If it makes a slight error in judgment on, say, step 2 of a 10-step problem, it's stuck on that wrong path for the rest of the answer.
So it's essentially winging it.
Yeah, pretty much.
It's like a very articulate person giving a speech without notes, just hoping the sentence makes sense by the time they get to the period.
That's a perfect way to describe it.
But Gemini 2.5 Pro with DeepThink kind of threw out that linear model. Instead of one path, it activates multiple AI agents simultaneously.
Yes, it branches out.
I'm picturing this almost like a police precinct. Instead of a single detective trying to solve a case linearly, like finding one clue, then looking for the next, you have an entire precinct of detectives investigating different leads simultaneously.
Okay, I like where this is going.
Right. They are all out there. Then they gather in a briefing room, argue over the evidence, and then present one unified bulletproof theory to the chief.
What's fascinating here is that while that's a great visual, we need to elevate that analogy just a bit to understand the actual mechanism.
Okay, how so?
Because in a real precinct, detectives can get attached to bad theories. They can follow false leads for weeks.
Oh, sure. Confirmation bias.
Exactly. But in the DeepThink architecture, there is a built-in judge overseeing that briefing room. It's this advanced reinforcement learning system.
But wait, doesn't spawning all these different AI agents at once just multiply the chances of it hallucinating wildly in different directions? Like, aren't you just creating a dozen opportunities for it to confidently lie?
Well, no, and that is the exact problem the reinforcement learning system solves. As those parallel agents branch out and start generating different hypotheses, say one agent tries a geometric approach to a math problem while another tries an algebraic one, the system is constantly grading their intermediate steps in real time.
Oh, wow. In real time.
Yeah, it evaluates the logic step by step. If an agent proposes a step that violates a known mathematical rule, the judge instantly scores that path with a low probability of success.
So it throws out the bad evidence immediately.
It doesn't just throw out the evidence, it cuts the power.
Wait, really?
Literally. It stops that agent from processing any further and reallocates the computational resources to the agents that are making verifiable logical progress. It's pruning the dead branches off a tree while the tree is still growing.
That makes a lot of sense. It forces the agents to only build their case on verified facts, rather than, letting them wander down a hallucinatory rabbit hole.
Exactly. A classic way the source material explains this is comparing a novice chess player to a grandmaster.
Okay.
A novice looks at the board and calculates maybe one move ahead at a time. But a grandmaster sits in silence and simulates dozens of entire complete matches simultaneously in their head.
Right, seeing all the branching possibilities.
Exactly. They play out the consequences of every possible move before they ever touch a piece. In computer science, this concept is known as allocating more compute at inference, or test time compute.
So let's define that term really quick, because inference gets thrown around a lot.
Yeah.
What is the difference between training compute and inference compute?
Good question. Training compute is the massive amount of server power and time spent teaching the AI how to understand language and concepts. This happens before it is ever released to the public.
Right, the learning phase.
Yeah. For years, companies spent billions there and then made the actual consumer product, the inference phase, which is the exact moment the AI answers your specific prompt. They made that as lightweight and fast as possible.
So it's cheap to run.
Right. But test time compute, or inference compute, completely flips that. It spends a staggering amount of processing power at the exact moment you ask the question.
Which explains the slowing down you mentioned. It is spinning up thousands of virtual processors, specifically to simulate all those parallel paths, just for my one question.
Precisely. It is deliberately sacrificing speed to allow that exhaustive multi-agent debate to unfold.
Okay, so the natural follow-up is, because Google is spending all this massive test time compute to simulate these paths, does this extra effort actually produce groundbreaking results?
Oh, absolutely. The data is incredible.
That leads us straight to the hard evidence.
Yeah.
We have to look at the benchmarks from Google DeepMind's July and August 2025 reports. And the one that really stood out was mathematics.
Yes.
Why is math the ultimate kryptonite for standard AI? Like, we have had calculators for decades, right? Shouldn't an advanced neural network be great at math?
Well, calculators do arithmetic. AI models are tasked with advanced mathematical reasoning and complex proofs, which is an entirely different beast.
Right, because it requires logic.
Exactly. Remember how we talked about standard AI being a predictive text engine? Guessing the next most likely word based on statistical patterns works brilliantly for, say, writing a poem or translating an email. But math is completely unforgiving. If you are solving a 20-step mathematical proof and you probabilistically guess the wrong variable on step 3,
the entire rest of the proof falls apart. You can't fake your way to the end of an equation just by sounding confident.
you absolutely cannot. Mathematics requires rigid, undeniable logic at every single node of the problem. That is why traditional language models failed so spectacularly at Olympiad-level math.
But DeepThink changed that.
It did. Because of that parallel agent structure where it tests and verifies every intermediate step, an advanced version of DeepThink achieved a gold medal level at the 2025 International Mathematical Olympiad.
That's insane.
It also got bronze in official evaluations, hitting near 99% on the AE 2025 math test.
Near 99%. On a test where what a brilliant human mathematical prodigy might really struggle.
Oh yeah, it's designed to stump the brightest minds on Earth.
That is genuinely difficult to wrap your head around. But it wasn't just math, right? I was looking at its performance on something called Humanity's Last Exam, which, by the way, sounds incredibly dramatic. What exactly is that?
It is dramatic, but for a good reason. It was a benchmark created specifically because AI was maxing out all the traditional tests, like the bar exam or medical licensing exams.
Okay.
Humanity's Last Exam was designed to be the ultimate test of expert-level, highly obscure, multidisciplinary human knowledge.
Like PhD level stuff.
Beyond that, really. These are questions that specialized PhDs struggle to answer without days of research. And DeepThink scored around 34.8% on that exam without using any tools.
Which, sounds low to a layperson getting a 34 on a test.
Yeah.
But in the context of this specific exam, that was a massive improvement, right?
A completely unprecedented leap over any previous model.
And it delivered excellent results in coding, too, right? In competitive programming environments like Codeforces and LiveCodeBench. And Codeforces isn't asking an AI to build, like, a simple HTML website.
Far from it. It's a highly competitive platform where elite human programmers race to solve complex, multi-step algorithmic puzzles. DeepThink was able to simulate different coding approaches, compile them internally, test them for edge case errors, and then deliver the optimal algorithm.
Here's where it gets really interesting for me. Okay, doing this with math and code is one thing. Those are very structured, logical languages.
Sure.
But looking at the specs for this model, the thing that truly blew my mind was its multimodal power. It boasted a 1 million token context window.
Yes, a massive context window.
For those of us who aren't software engineers, what actually is a token? Are we talking about a million words?
Well, a token is essentially a piece of data the model can understand. In text, a token is usually about 3/4 of a word. So a million tokens is roughly 750,000 words.
Which is, what, several thick novels?
Easily. But tokens aren't just text anymore. A token can be a tiny patch of pixels in an image or a fraction of a second of an audio waveform.
Okay, so with that much room, you could feed it hours of video or audio. But how does deepthink actually apply its multi-agent debate to something as messy as a massive video file? I understand debating an equation, but a video.
If we connect this to the bigger picture, in 2025, when compared to competitors like OpenAI's O3 or Grok 4, DeepThink's unique advantage was exactly this: its ability to do exhaustive exploration of massive, complex inputs.
Okay, but how does it watch the video to explore it?
It translates the pixels in the video frames, the spoken words in the audio track, and the text on the screen into massive strings of numbers called vectors.
Vectors.
Yeah. It maps everything into a shared mathematical space. So the visual of a dog, the sound of a bark, and the word dog all end up in the exact same mathematical neighborhood.
Oh, I see. So the agents are all speaking the exact same mathematical language, regardless of whether they're analyzing a pixel or a spoken word.
Correct. So when researchers use it for, say, scientific discovery or deep paper reviews, the parallel agents divide and conquer. One set of agents might analyze the audio transcript for inconsistencies. Another set scans the visual frames for physical evidence.
And a third set could be cross-referencing all of that with a 500-page legal document you uploaded.
Exactly. If the audio claims one thing, but the visual cues suggest another, the agents literally debate that discrepancy mathematically until they find a high-confidence resolution.
That is staggering. You're working with the AI as a collaborator at the frontier of human knowledge.
It really is.
But, hearing about gold medals and million-token windows sounds like a total utopia. But mind-blowing benchmarks don't automatically equal a flawless, accessible product for you and me. Let's look at the very real friction of using this tool.
Right, because there were significant barriers to entry.
The friction was very real. Let's talk about the cost first. Spinning up thousands of virtual processors is resource-heavy.
Very. And Google had to pass that cost on. Accessing DeepThink required a Google AI Ultra subscription, which was a steep $250 per month.
So what does this all mean? At $250 a month and waiting hours for an answer, is this actually useful for the everyday person you or I might know? Or is this just an incredibly expensive toy for elite competitive programmers?
This raises an important question about access and equity. It wasn't built for the everyday person drafting an email. It was strictly for asynchronous high-level work. And that created a serious equity issue regarding who gets access to top-tier reasoning tools.
Because if you don't have the $250, you're left behind.
Exactly. The lack of immediate democratization meant only well-funded institutions or elite developers could afford these cognitive superpowers. And on top of the cost, there were strict daily limits. You were only allowed dozens of prompts a day.
Dozens. If you're used to rapid-firing questions, that completely breaks your workflow.
It forces you to be very deliberate. And the latency, because deep thinking takes time, waiting for an answer could stretch from minutes to sometimes hours for extreme cases.
And we should also mention, it wasn't flawless, right? Even with all this reasoning, the model card noted that safeguards were still heavily needed.
Oh, absolutely. Large models still carry risks of hallucinations and biases. Even with reinforcement learning, pruning bad paths, it wasn't perfect.
So you have this expensive, slow, limited tool that is still capable of bias. But for those who could afford it, the broader impacts on society were huge.
Massive. We saw the potential disruption of creative and scientific jobs. If a firm can pay $250 a month for DeepThink to review 500 scientific papers and propose a new methodology over a weekend.
That's a job that usually takes a team of junior analysts weeks to do.
Right. And as the field raced against competitors like Anthropic and XAI, there was this growing dependency on AI for high-level research.
It completely disrupts the apprenticeship model. Which kind of brings us to the core journey of this deep dive. Gemini 2.5 Pro with DeepThink proved that AI evolved past simply regurgitating data quickly.
Yes, by utilizing parallel agents to debate and hypothesize, it became a deliberate, thoughtful collaborator.
Albeit an expensive and slow one.
Definitely.
But the value here, what you really need to take away today, is understanding the mechanics of test-time compute. The future of AI isn't necessarily about speed anymore.
No, it's about the depth of automated reasoning.
Which leaves us with a new, kind of lingering question to ponder on your own. It builds directly on that growing dependency on AI in research that we just mentioned.
That's a heavy thought.
It is. If we increasingly rely on platforms like deepthink to do the exhausting, multi-path intellectual labor for us, like if we start outsourcing our internal debates, hypothesis testing, and outside-the-box branching to machines, what happens to the human skill of prolonged solitary contemplation?
Yeah.
As AI becomes the ultimate deep thinker, will human deep thought become a lost art? Or will this simply free our minds to explore entirely new, unimaginable intellectual frontiers?